Hi, how is it going? Welcome to Code with Z. Today's question is LeetCode number 35, search insert position. Now I want you to know that I'll explain and visualize everything in the coming slides, literally everything. But for the sake of reading the question, let's see what the question is actually asking us for. So as we can see, we're given a sorted array of a bunch of integers, and we also have a target value. We gotta return the index of this target if it is actually found inside of the array, and if not, we gotta return the index of where it would actually be if it were inserted in order inside of our array. Now, what does this even mean? Well, if we check our examples here, for example, this is our array that has 1, 3, 5, 6 inside of it, and our target number is 5. So does 5 exist in this array? It does, so we're gonna return the index of this position, and that's gonna be 2. But if we check our second example, our target number is 2, and this is our array 1, 3, 5, 6. So does target number, which is 2, exist in this array? No, it doesn't. Well, if it did exist, which index would it actually have? Well, if we check, this is 1, right? And our target number is 2. So because our target number is one number greater than 1, it would actually be next to 1, right? Well, this number 1 has the index of 0, and if our target number would actually be inserted in this array, it will have the index next to this 1, and because this has the index of 0, our target would have the index of 1. This is basically it, and we also have to make sure that we solve this problem with the time complexity of log of n. Alrighty, let's solve this together, and don't worry, I won't finish this video until I make sure you fully understand how to solve this problem once and for all. Building these slides took me ages, but I hope it provides you with value. Now, this is our sorted array, and this is our target number that we gotta search for inside of the array with a time complexity of log of n. Now, I don't know about you, but for me, each time I hear sorted array, searching, and a time complexity of log of n, I immediately think of binary search. Now, for solving the problem that we saw, we're gonna use binary search, but we're gonna make one modification to it. So understanding how binary search works under the hood is really important for solving this problem. So let's visualize binary search together. In binary search, we have 3 important variables. One is called left, and left is gonna be equal to the index of the first element inside of the array, which is 0. And as you can see, this number has the index of 0, which is why left is pointing to this number. And the next variable is gonna be right, which is gonna be equal to the index of the last element inside of the array. And as you can see, this is the last number inside of our array. So our right variable is gonna have the index of this number, and it's gonna be pointing to the number itself. Now, when we have left and right, we can calculate another variable that's called mid. And mid is basically left plus right divided by 2. And as you can see, it's literally in the middle of left and right. So it's going to be equal to the index of this number that's in the center of our array. That's why it's called middle. Now, each time we calculate middle, we're going to ask ourselves if the number that middle is pointing to is equal to our target number. Well, is 5 equal to 7? Not really. So we're going to be like, all right, I guess this is false. So let's do something about it. And we're going to be like, because this array is sorted, we can clearly see that any number that comes before the middle is smaller than the middle, right? And any number that comes after the middle is basically greater than the middle because the array is sorted, right? So we're gonna ask ourselves, is the target that we're looking for smaller than the middle number? Well, is 7 smaller than 5? Not really. So we're gonna be like, all right, because our middle number is actually smaller than target, we can see that all of these numbers are not gonna be our answer. Why? Because all of these numbers are smaller than our middle number, and our middle number itself is also smaller than the target. So we're gonna ignore all of these. And we're gonna be like, because we're gonna ignore all of these, bring left to middle plus 1. Like so. And then we're gonna calculate our middle again. As you can see, the middle number between these two is gonna be here. And now middle is pointing to 8. We're gonna ask ourselves again, is 8 equal to 7 because 7 is our target? No, really, this is false. So we're gonna be like, all right, is 7, which is our target, smaller than our middle number? Well, yeah, this is true. So we're gonna be like, all right, because our middle number is greater than our target, we can clearly see that any number after it is not gonna be the answer because our middle number is greater than the target already, and any number that comes after the middle number is gonna be also greater. So we're gonna ignore all of these and we're gonna ask right to come to this side. We're gonna be like, right should be equal to middle minus 1. Now we're gonna calculate middle again, and this time it's gonna be pointing to this number here, and we're gonna ask if 7 is equal to 7, meaning we're gonna ask if the number that our middle variable is pointing to, which is 7, is it actually equal to the target number? Well, yeah, So we're gonna be like, awesome. And we're gonna return our middle variable because it literally has the value of this position here. It's basically the index of this number, so we're gonna return it. This was a normal binary search, but let's see what will happen if we actually look for a number that doesn't exist inside of the array. As you can see, our target is 6 and we don't have 6 here. Now I'll explain the structure of the algorithm and then I'll visualize everything. So the first thing that we need is basically a left variable, just like we saw in the previous slides. And this is gonna be equal to 0 because remember in the previous slide we said left is gonna be equal to the index of the first element inside of the array, and the index of the first element inside of the array is gonna be 0. And then we're gonna have right, and right is gonna be equal to the index of the last element inside of the array. And this is literally saying the same thing. So as you can see, nums.length, meaning the length of this array, which is 1, 2, 3, 4, 5, 6, 7, meaning 7 minus 1, that's gonna make it 6. And if we check, this number has the index of 6. And because we're searching for something, we're gonna need a loop so you can actually loop through this array. So this is gonna be representing our loop, and anything inside of it is gonna be inside of the loop. We're gonna keep on looping as long as our left variable is smaller than or equal to right. So this is the condition for our loop. Inside of the loop, we're gonna have to calculate our middle variable just like we saw in the previous slide. So we're gonna say middle is gonna be equal to left plus right divided by 2. And when we actually calculate it, we're gonna say nums of mid, meaning the number that our middle variable is pointing to, is it equal to target? If this is true, meaning if our middle variable is pointing to our target number, we're gonna be like return mid because that's the index of the number that we were looking for. If this is not true, we're gonna be like, is target smaller than nums of mid? So is target smaller than our middle number? If it is, right should be equal to middle minus 1 because that means anything after our middle number is actually greater than our target number. So we don't want them, and we're gonna be like, check the left side, just like we saw in the previous slide. And if that was not the case, else, meaning if our target number was greater than our middle number, we gotta ignore all of the left side because all of those numbers are gonna be smaller than our target number. So we're gonna be like left, come to the right side. And that's why we say left should be equal to mid plus 1. And then at the end, and this is really important, if we don't find an answer, we're gonna usually return minus 1. And this is basically a binary search. But the problem asks us that if we don't find the answer, we gotta return the index that's actually suitable for that number inside of the array. And for this, we're gonna return left. This is the only change we need. And you might be like, why left? Why not right? And how does all of this work? Well, let's visualize all of this so you can see how it actually works with your own eyes. And then at the end, I'll explain it to you as well. So the first thing that we do is initialize left to 0, right? Well, let's do that. Now left is equal to 0 and it's gonna be pointing to this number. Then right is gonna be equal to nums.length minus 1. Nums.length is gonna be 7 minus 1, that's gonna be 6. And that's gonna make right be pointing to this number here. And then we're gonna enter this loop and we're gonna calculate our mid. So 0 plus 6, 0 plus 6, that's gonna be 6. Divided by 2, that's gonna give us 3, meaning middle is gonna be 3, so it's gonna be pointing to this number. So nums of mid is gonna be equal to 5, and our target is 6. So is 5 equal to 6? Not really. So we're gonna check this else if, and we're gonna say, is target, meaning 6, smaller than 5? Well, not really. So because this statement is also false, we're gonna fall inside the else and we're gonna say left should be equal to middle, meaning 3 plus 1. And that's gonna make left be equal to 4. And as you can see, we literally ignored all of these and we came here. And we're gonna enter the next round and we're gonna keep on looping because left, which is equal to 4, is smaller than or equal to right, which is 6. So we're gonna keep on looping. We're gonna say 4 plus 6. That's gonna be 10. 10 divided by 2, that's gonna give us 5. So middle is gonna be pointing to this number. So we're gonna say if nums of mid, meaning 8, is equal to target, meaning 6, do the following. Well, 8 is not equal to 6, and this statement is gonna be false. So we're gonna check the else if. We're gonna say is target, meaning 6, smaller than 8? Well, yeah, this is true. So we're gonna get inside of this else if, and we're gonna say right should be actually equal to 5 minus 1, and that's gonna make right be equal to 4, and we're gonna bring it here like so. And now right is pointing to this number, and we're gonna keep on looping because left, which is 4, is smaller than or equal to right, which is also 4. So we're gonna calculate our mid, which is 4 plus 4, and that's gonna give us 8. Divided by 2, that's gonna give us 4. So now middle is gonna be pointing to this number. So nums of mid is gonna be equal to 7, and our target is 6. So are these two equal? Not really. So we're gonna fall inside the else. This target, which is 6, smaller than nums of mid, which is 7. Well, yeah, this statement is correct. So we're gonna get inside of this else if, and we're gonna say right should be equal to middle, which is currently 4 minus 1. So 4 minus 1, that's gonna make right be equal to 3. And that's gonna make right be pointing to this number here. And then we wanna keep on looping, but left is 4 and right is 3. And this condition is not true anymore. So we're not gonna keep on looping and we're gonna return left, which is equal to 4, and this is gonna be the correct answer. Why? Well, if we check, left is pointing to this position here, and if we actually check, all of the numbers that come before this position are smaller than our target number, and all of the numbers that come after it are also greater than our target number. So it's the perfect position for our target number. And this happens every time we don't find the answer. Every time, because this is our condition, right? Left is gonna be one number greater than right, and that's gonna make it point to this position that literally all of the numbers before it are gonna be smaller than the target that we were looking for, and all of the numbers after it are gonna be greater than the number that we were looking for. So it's gonna make it the perfect position to insert our target number. And this is how we solve this problem. Now let's code this together. Alrighty, so first of all, we're gonna define our left variable, and that's gonna be equal to 0, just like we saw in the slides. And then below this, we're gonna define our right variable, and this is gonna be equal to nums.length minus 1. Again, just like we saw in the slides. And then below these two, we're gonna have our loop. We're gonna say while left is smaller than or equal to right, keep on looping, and we're gonna enter this while loop. Here we're gonna calculate our mid. We're gonna say let mid be equal to left plus right divided by 2. But for example, if our left variable is 2 and our right variable is, for example, 5, this is gonna be equal to 7, because 2 plus 5 is gonna be 7, and 7 divided by 2 is gonna give us 3.5. And we don't want this because we don't have a number that has the index of 3.5. We gotta remove these decimals. So we're gonna wrap this around math.floor to actually get rid of that decimal, like so. And after we have our middle variable, we're gonna check if that's our answer. We're gonna say if nums of mid is equal to the target, return mid, like so. And else if target is smaller than nums of mid, we gotta make right be equal to mid minus 1. Else, meaning if the target is greater than our middle number, we're gonna say left should be equal to mid plus 1. And then at the end, if we don't find the answer, we're gonna return left. Now, let me run this. Moment of truth. Yep, as you can see, all 3 of the tests are passed. Let me submit this. Drum roll, please. I'm just kidding. Let's see if we're gonna get accepted. Yep, and we're beating 64% of all of the other submissions. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.